This is the solution for number 12 in the AP Current Electricity problem set. This is a really neat practical application problem, real life problem here. We have an electric heater rated at 1300 watts, a toaster at 1000 watts, an electric grill at 1500 watts, and those three appliances are connected in parallel to a common 120 volt circuit. So these three devices are all plugged into the same outlet, so to speak. And our questions to answer here are: how much current does each appliance draw? And then B, is a 30 amp circuit breaker sufficient in this situation? And explain why or why not. All right, so let's go back and start over here. Any electrical device, heater, toaster, grill, are all considered resistors. So electrical heater, we're going to label this R1, is rated at 1300 watts. Watts is the unit of power, so we'll call this power P1 because it belongs to the electric heater. A toaster, so a second resistor at 1000 watts, so we'll call that P2. And an electric grill, so we'll call that R3 at 1500 watts, and we'll call that P3. They're connected in parallel, very key piece of information there, to a 120 volt circuit, and this is the total voltage available to all the devices. All right, so we're going to start by drawing this circuit. We'll bring down this to represent our 120 volt power supply, and then we need a resistance symbol for each of our heater, our toaster, and our grill. We'll draw appropriate connecting wires. So label each one. Those R1, R2, and R3. Let's also label the power for each one, the power dissipated or power used by each one. 1300 watts, that's P1. 1000 watts, that's P2. And 1500 watts, and that's P3. Okay, how much current does each appliance draw? That's I. And then they give us a circuit breaker question to answer, and B, more on that to come. All right, so they want the current in each of these electrical devices. We'll call that I1 for the heater, I2 for the toaster, and I3 for the grill. All right, so there's our circuit. And again, a nice practice here. In order to calculate current, we need to know two other electrical quantities. Do we? Well, we know one electrical quantity for each device, and that's the power that each one uses. Do we know the resistance? No. There's only one other electrical factor, and that's voltage. What do we know about voltage in parallel? And that, of course, is that it remains constant. So we know that the heater, the toaster, and the grill both all get 120 volts, and we can use that to our advantage to calculate the current. So we're going to start with the heater, which is R1. And the formula that relates the electrical quantities that we're looking for and the ones that we know is power equals current times voltage. So P1 equals I1V. Now the power is 1300 watts for the heater. And it uses 120 volts. So I1, when calculated, is 10.8 amps. Now shift to the toaster. resistor R2. Repeat that calculation, but with its electrical quantities. It uses 1,000 watts power and 120 volts. So the current through the toaster is 8.33 amps when we divide. Lastly, the grill, R3, power equals current times voltage. It uses 1,500 watts, 120 volts. 1,500 divided by 120, 12.5 amps. So there are the three answers we're looking for, the current in each one, and those are our answers to A. For B, they want and give us a situation in which these devices are connected in a circuit that has a 30 amp circuit breaker, and they want to know whether or not that is sufficient for this circuit or not. In order to answer that question, what they're really asking us and telling us is that the total current limit on this particular circuit is 30 amps. If that total current is exceeded, what happens in the circuit breaker is that it flips an electromagnetic switch and turns the circuit off because it's exceeding a safe level of 30 amps. So what we need to do is we need to calculate the total current for these three devices that we just measured in A, part A, and see what our total is here. In parallel, the total current is the sum of the individual currents. So the total current is going to be 10.8 plus 8.33 plus 12.5 amps. And when we add those up, we get a total current of 31.6 amps. What that tells us is that no, our 30 amp circuit breaker is not enough, is not sufficient enough to support all three electrical devices. So if we were to plug all three of these into that circuit, it would open that 30 amp circuit breaker and cause all the devices to turn off. What this means is we can only operate 2 out of the 3 devices safely at any given time. So there you have it. There's number 12 of the current electricity problem set.